Hello, I think we're live now. For those who don't know me, my name is Friedt. I am recently acquired by Tenstorrent, formerly of Meta. And yeah, this is my talk on the POSIX roadmap for LTS version 3. So just so in case you're not aware what LTS means, it's long-term support release. That's the version of Zephyr that's supported for at least 2.5 years. It overlaps with the previous LTS release by 6 months. And the LTSv3 release is scheduled for July 26th of this year. And one of my roles in the Zephyr community was LTSv2 maintainer. So what that means is that by this time next year, I will not be your LTS release manager. You will be in the very capable hands of Alberto Escolar, native POSIX and Arch maintainer. So I just wanted to say the last 2.5 years have been worth every second. So thanks very much, Zephyr community. And then I guess I'll be, yeah, here we are. So today we're going to talk about what role POSIX plays in Zephyr, a little bit about how it's organized, kind of the goals for LTSv3. This is almost like a refresher of a talk that I gave last year at EOSS because I wanted to follow up and make sure that I was on track and had all the community engagement and that sort of thing. So yeah, I'll just get into it because I think the topics are self-descriptive. So POSIX is a library that lives between the application kernel and subsystems. Ideally, it would be a very thin interface between those things. And I mean, portable operating system interface is kind of self-descriptive. And the last part of that is important because the interface is meant to be consistent, not the implementation. That's how POSIX applications achieve source level portability. Here's a brief overview of POSIX in Zephyr. I'm not going to go over the whole thing. It's just here for reference. I find it kind of fascinating to see how it's changed hands over time. In any case, it's been very much adding things on an as-needed basis, so almost in an ad hoc fashion. But yeah, it started out with sockets way back in the day, and then now we have dynamic thread stacks and everything. So I guess at the very end of that graph is where you'd probably see Tenstorrent now as maintaining the POSIX subsystem, or API, I should say. So one of the topics that we have to discuss, just because it's probably not as familiar to many people, is this concept of application environment profiles. So effectively, we have this nice Venn diagram that's fully concentric, which is great. So at the bottom, we have the base definitions. Actually, that should be updated to system interfaces. My mistake. I'll fix that on the slide. Above that, we have PSE5.1. Above that is PSE5.2, and then PSE5.3. There's also a PSE5.4, which is for effectively a multi-purpose real-time system, like a Linux desktop, for example. There has been a little bit of a change since the early days when this terminology was introduced. So originally they were called AEPs, which somehow gets translated to PSE. It could potentially be like a multilingual thing. I didn't find an actual definition for that acronym, but that was way back in 2003. So I think it could have been 2008, where they switched over to sub-profiling option groups. So that's instead of this application environment profile. And I guess with all the identifiers that I'm going to be listing in the coming slides, the way that you differentiate between an option group and an option is that the option has an underscore prefix. And this should be corrected. I don't know if you can see, no, you can't see my pointer. Where it says base definitions, it's actually system interface, sorry. So I guess starting off, the very basic fundamental requirements are these, basically like asynchronous I/O, which we actually do not support. I don't know if there are a lot of people out there that do support it. Barriers, clock selection, et cetera, et cetera. I'm just going to try and breeze through this part. So if there are any questions at any point, feel free to just interrupt me. That's fine. But these are all the fundamental building blocks. We've got multi-threading, synchronization, real-time signals, memory mapping. Yeah, Keith.
Have you started labeling which of these you are never going to do? Like these are not going to be part of Zephyr, like say for instant real-time signals?
Yeah, that's going to be part of the documentation, and we have started labeling it. It's kind of subtle right now, but hopefully that gets clearer as the documentation matures. So an interesting tidbit is that real-time signals here are mandatory. I don't know what number it is, like, you know, the 8th down from the top, whereas like the generalized signals are not. So it's actually kind of interesting. So moving on, we have PSE5.1, which is the minimal real-time system profile. It has some additional things, POSIX device I/O, like standard in, standard out, standard error, fopen, etc. We've got file locking, single process, XSI threads, which just kind of adds the ability to set and get your thread stack to a static array, a static memory address. And then signals, of course, which, as it turns out, is critical for high-resolution timers, which is another thing on the to-do list. And then, of course, as the list goes on and on, I'm going to skip again to the closer to the bottom. POSIX or POSIX shared memory objects are actually quite important, and we'll get to that a bit more later. But right now, without an MMU, like we do have an MMU API internally, but I think it might be best for us to assume that we don't for the purpose of conformance until we can actually tie that down. So we'll get to that in a bit. The last thing I wanted to mention is the POSIX thread sporadic server. It's an interesting way to introduce non-determinism into your execution of a multi-threaded system, which is good just to test the robustness. And then, of course, PSE5.2. This is a real-time controller system. And what you'll notice is that these are just additive onto the previous system profiles. So the delta is actually much smaller than what our documentation page makes it seem. Of course, like this one just adds math support, file descriptor management, which is things like dupe, fgetpos, ftruncate, file system accessors, like change directory, remove directory, stat. Keith?
Does that CLI map include the POSIX extension to the CMap library?
I do not know the answer to that question. But I think that I know you've asked me that before. I think the thing is with POSIX, they always defer to the C library. So that's a good question. I think that's probably beyond, well, I can only do so much. I'll continue on. So mapped files, of course. And again, without an MMU, this has to be a physical address if you're mapping files. Yes? Oh, repeat the question. Sorry. Keith's question was, do we have any details on the POSIX extensions to the ISOC math library routines? And my answer is I don't know. And definitely, we haven't taken any significant measures to support like Bessel functions or anything. So if it's supported in PicoLibC, then I guess it would be supported. Another interesting one is actually message passing. So yeah, of course, like message queue send, message queue receive, MQ send, MQ receive, that sort of thing. And continuing on, we get to the dedicated real-time system. I hope this visualization helps. Does that help? Yeah, good, okay. So in PSE5.3, again, it's a relatively small delta on top of PSE5.2. So with this, we get to multi-process POSIX systems. Processes are not something that we support in Zephyr. I think, for the most part, we proceed under the assumption that we are running in a single process, a single address space, although there's probably some minutia in terms of how that's interpreted and so on and so forth. So deviations from the POSIX specifications are, of course, documented, and we'll try to make every effort to document those. Who knows though? Maybe in the future we will support some actual processes with separate address spaces. And then again, POSIX networking, which is awesome. Actually, Yuka just helped to finalize that, and of course, he started that whole effort to support POSIX networking in Zephyr. So, another thing, I think I skipped this on a previous slide. I'm going to jump ahead again. POSIX CPU time here refers to the amount of time that a process has, including all of the children, all the threads that run in that process, how much CPU time it's actually taken up. There's a similar POSIX thread CPU time, which I think would be extremely critical for us to implement. That's a bit of a low-hanging fruit thing. So I'll try to summarize any missing pieces at the end, and hopefully we can, entice some new contributors and that sort of thing. And of course, sporadic server is very similar to the thread sporadic server, but at this level, it's the process sporadic server. Yeah, that's a little bit tricky. So I mean, technically speaking, if we build Zephyr using the sporadic scheduler, then that would be supported. We don't have that yet, so it's a little bit outside of the scope of what we can accomplish with what we have. And that's why I have this little cross logo thing icon. So that is actually sort of consistent with the upstream Zephyr documentation. But again, we're going to try and improve the documentation so that there is a more structured way to represent deviations. So I guess a question that everybody always asks me is why POSIX? Why POSIX and Zephyr? It's a portable, mature API. You get portability. You get a confidence that your application will run from one target to the next, which is really useful. It's been incredibly useful for all network operations. There's a little bit of it sort of served as inspiration for a lot of our scheduler API and a lot of our file system API. And of course, this is very approximate, but approximately 2 billion POSIX devices in use as laptops, that's the little icon, desktops, and I have a filing cabinet there as a file server. So there are many POSIX systems out there. And of course, bigger than all of that is mobile. Mobile is everywhere. Everybody has a supercomputer in their pocket nowadays, all running a POSIX operating system. And even within that device, you could have like a POSIX RTOS, such as Zephyr or something like that, running on one of the real-time cores, which I find fascinating. And the last one I wanted to point out is, this is again a rough approximation, but there are a lot of incumbents in this field where you have a real-time POSIX certified RTOS that's controlling the infotainment system and perhaps some of the other aspects of an automobile. It's usually safety certified and all that stuff. I'll get to that a bit later, but automotive is actually a pretty key market. So our goals, this is actually a really quick section, recapping what I had stated last year. So we want all of the POSIX system interfaces. Those are what I called the base definitions earlier. It was mislabeled, my mistake. I'll fix that later. We want to support PSE 5.1, 5.2, and 5.3 so that we can give so we can give POSIX customers a good base to start off with, so they can move their applications and libraries in with ease. And then, of course, we wanted to improve maintainability. We wanted to improve conformance and portability. And documentation is actually the last one, of course. So now we're on to how's it going? How it's going. So one of the things that came out almost immediately after EOSS last year was that the source tree needed to be restructured. We needed to make things a little bit more organized, like how we typically do in Zephyr, where you have, I should have shown my screen here, but how you typically have like a kconfig.feature A, kconfig.feature B, and then you include those kconfigs from the main kconfig. It makes everything much more modular and scalable, I would say, because then you can keep all the details in a separate file. CMake doesn't have to kind of follow that rule to some extent. And then, of course, conformance options. So there are a couple of different facets to conformance. One is application conformance, which is when the application says, I want POSIX C source equal to the 2017 version of the specification. And that key will allow all the various functions and structs and definitions to be provided in the C header file that you're including. And then, of course, there's application conformance, which is if your implementation implements, these, Friedt or Friedt, all these combinations of things, then you can say that you support this sub-profiling option. So that's kind of the emergence of that came out of the PSE sort of thing. So, and then of course, actually Keith is right here, which is good. One of the things that we're really striving to do is to ensure that we can incorporate as much stuff from external C libraries as possible when that external C library has an already mature suite of POSIX functions. So Keith and I will definitely follow up on that. Yeah, so since last year, the test suite has increased by about 1,000 lines of code. Some of that has actually been us shrinking other test suites within POSIX while simultaneously adding new lines of code. So the test suite is growing, which means that we're doing our homework, we're making sure that we're not breaking things, we're compiling against multiple libcs, so it's pretty good. One thing that really kind of irked me, and it's still an issue, and I'm hoping that Kong, who's a collaborator, can help with this too. We need to go through the various POSIX Kconfig options and make sure that they line up almost directly with the specification name. So for example, config POSIX networking, POSIX, sorry, I mix the pronunciation regularly. Config POSIX networking, which is a Kconfig option, should translate directly to enabling the POSIX networking option group. And the same can be said for various options within POSIX. Portability, yeah, I think I already mentioned, and sorry, I copied this from the previous slide, but we're testing against the minimal libc, newlib, and picolibc. And I think actually in some cases, at least for a while, we were testing against the native libc, if only by accident. Documentation. I personally feel that it's improved. I think we still have a ways to go, but effectively we restructured the POSIX documentation and broke it down into smaller, manageable chunks instead of being a single monolithic page. So I personally find it better, but one thing that's missing, as I mentioned, is we actually don't have function level or struct level doxygen. So, and that's a huge endeavor actually. So I think one of the only feasible ways to do this is actually to either hire an army of new graduates, interns, or whatever, to do this for you, or basically write a parser to kind of automatically generate, or maybe just ask ChatGPT. I have no idea. So definitely, if anyone's interested in helping doxygenate some of the POSIX functions, that'd be great. And ideally, we wouldn't just copy stuff right out of the spec, because I think that's copyrighted. We'd have to use our own words and that sort of thing. Okay, this is where I guess it gets a little bit more interesting. So the system interfaces, which I incorrectly mislabeled base definitions earlier, for the most part, this is pretty good. Excuse me. So the only two critical ones that are missing right now are map files and memory protection, which is, it has a little bit of a nuance, especially on MMU-less systems. It is possible to do that, but for example, if you're mapping a file on a system that doesn't have an MMU, it's got to be a physical address. So you can make that happen, but it's going to take some additional checks. On a system with an MMU, of course, you'd have paged memory and that sort of thing. So you can just take an arbitrary address that the MMU gives you and apply that to whatever memory mapped file you have. And then, of course, you're going to intercept those I/O calls to that file when you're doing things with it. A lot of these things weren't implemented last year, so it's actually kind of great to see them implemented. And it's not just me, it's not just Kong. We've had a lot of people come with kind of drive-by PRs, which is fantastic. And I encourage everybody to keep contributing because I think it's fantastic. Something that I'm doing myself right now is actually implementing signals. This might sound distasteful to some because signals, for the most part, introduce, especially if you're using signals to kill a thread, it introduces a lot of non-determinism into a system that is otherwise deterministic. So probably what we'll do is for those signals that would terminate a thread or a process, we might just ignore them unless you specifically say that you want that thread to be terminated. Because if you terminate the thread and it's got a bunch of resources associated with it, right now we don't have a way to free those resources automatically, like what's done on Linux, for example. Again, real-time signals, a major difference here between real-time signals and regular signals are that real-time signals have to be queued. They have to arrive in a determined order. They have to be handled in a determined order in order for the system to be deterministic. Really good opportunity if someone's new to Zephyr and they want to take a crack at some PRs. Thread safe functions, these are for the most part the _r variants of various things like readdir _r, because it gives you, of course, Picolibc already has this. I can see Keith kind of like shaking his head. But yeah, so ideally we would have support for POSIX functions even when we're using a different C library. So that's kind of the methodology there. And then eventually we would harmonize. Along with signals, real-time signals, regular signals, etc. I'm handling pthread kill right now, which is sending a signal from one process to another. So that's kind of interesting, I'd have to say. So I'm excited to land that soon. We've had one drive-by contributor just start doing stuff for POSIX device IO, which I find also fascinating. And I'm going to encourage them to keep doing that. So file locking, it sounds fairly trivial, but we'll see how that goes. I think that's another great first issue. And then the regular signals, which are handled with like a sig set and bit masking, that sort of thing. Yongkung did most of the work for that at some point. Oh, sorry, I'm just gonna get my water. Does anyone have any questions about any of the options or option groups so far? No? Okay. XSI threads extension, I think I already mentioned. It's just a way to set your thread stack. Of course, threads base. Currently only missing pthread kill, which I kind of consider almost done at this point. So. And of course, PSE 5.1 in terms of just the options. As I mentioned earlier, memlock, memrange, these are things that sort of assume that you have an MMU. If you don't have an MMU, it's very difficult to do this. And you might as well just say it's not supported, so E not sup sort of thing. Thread CPU time, we have all of the plumbing in place in Zephyr to make that happen any day. Anytime anytime someone wants to implement that, I'll gladly review it. If not, I'll be getting to it shortly. The other things like priority inheritance, protection, that sort of thing, most of these were contributed fairly recently by, again, like drive-by PRs. People that have probably been active in Zephyr at some point in history, but haven't been back for a while. So it's really good to see people coming back and making those contributions. Again, in terms of PSE 5.2, it's just a very small delta for this feature set. And it's almost misleading when you look at the documentation on the Zephyr project site. I think that's something we need to fix because on the project site, we kind of repeat all of the options from the previous PSE level. And so it actually looks like it's more daunting than it actually is. So progress is going pretty well. In spite of, the size of the list, we're at about 80% completion for this already. FD management, which is another thing like, duplication of file descriptors and that sort of thing. Getting the offset, that's in progress. So we've had recently one developer come in and start submitting PRs. File system. We've actually had the file system support for a very long time, and maybe I would skip back, but maybe it's better to avoid it, but file system support was one of the first things introduced way back in 2018. So it's mostly implemented. There are some additional things that we do have to implement, and that's actually another place in our documentation which is missing right now. So I did ask a recent contributor to fill it in, so hopefully that gets added. So with PSE5.2, POSIX shared memory objects are actually pretty important, especially moving on to the next level, PSE5.3. Trace support, I'm actually not super crazy about implementing this. Zephyr already has trace points. They might not be perfect, but they're there. If we ever want to really optimize this, we can potentially do that. So I'm tempted just to say like e-not-sup for POSIX trace. It'll be linkable, that sort of thing. Excuse me. But when you try and run that code, it'll probably just give you a log message that says, please use the Zephyr POSIX tracing API. And now moving on to PSE5.3, which is again just like a small delta over the previous revision. Multi-process, this is kind of out of our control at the moment. We're probably not going to support multiple processes for the foreseeable future. It probably won't be there for LTSv3, and it's certainly not going to be driven from the POSIX side. It's going to be a kernel thing. Pipes are like super easy. It's a unidirectional communication channel with a read end and a write end. So this is again like a great opportunity for our first PR. And then signal jump. Signal jump is, as much as it might sound intimidating, it's not that bad. You basically just mask your signals, or you save your signals, do your jump, and then you restore the signals coming out the other end. Pretty simple. Progress is going pretty well for this as well, in spite of what the documentation says on the Zephyr webpage. So I think that's something that we're probably going to have to correct sooner than later. One area that I think the network maintainers will have to jump in and add is raw socket support. So currently we have a number of different socket protocols, but as far as I'm aware, I don't believe we have raw sockets. That might have changed recently, because I know that Yuka added like a packet sniffer for the network subsystem. I don't know why the monotonic clock is here. Sorry, that's a typo. I'll fix that on the final copy. Monotonic clock, of course, like, I don't know if anybody watches Doctor Who, but are there any Time Lords in the audience? No, okay. We know that you're there. That's okay. So yeah, of course we need the monotonic clock for keeping track of stuff, but that's way back at PSE5.1. So I think probably like if all of the cards are played right, I think we might actually be able to get all of these checkboxes checked for LTSv3 release. Probably with the exception that we won't support, at least not at the beginning, paging of anonymous memory and memory mapping with virtual memory. So that's a bit of a niche, and I think currently it's limited to x86 and 64-bit ARM. So we've improved maintainability a bit. Conformance is getting there, but it still has a little bit of improvements to be made. Let's see what else. Portability, we're testing against multiple libcs, so it's pretty good. It could be better. I think I'd like to pull in a lot of the things sort of from PicoLibc, at least the style. So again, I'll be following up with Keith about that. Documentation is good. It could be better, but it's definitely an improvement. One aspect of this that I didn't mention yet, I sort of alluded to it earlier, was that automotive is actually going to be playing more of an increased role, I think. So there's a standard called AutoSAR, and specifically adaptive AutoSAR. I'll get into it in a minute, but within 24 hours of being at this conference, I was already approached by 2 companies involved in the automotive sector, and they were already asking for, when can we actually put Linux and Zephyr into a car and have it certifiable? That's a big question. I don't think we'll be there for LTSv3, but we'll probably be in a good place for our community members to get started. So as I mentioned, signals, that's something I'm working on right now. The next big thing, which would be kind of useful to unify all of the file operations and that sort of thing, would be something I call ZVFS, my mistake. So that would be putting like fcontrol or ioctl or read, write, that sort of thing on a central place where the various subsystems can leverage them all kind of in a more organized fashion, so that there are no layering violations and cyclic dependencies in the APIs. Because previously we had, for example, the network subsystem referencing POSIX and the POSIX subsystem referencing the network subsystem. With this, we break that dependency chain, so there's a third item that both networking and POSIX can depend on. There are some similar dependency chains and threading, actually, but that's actually not a pressing issue. So, and lastly, doxygen. I think it would be great if we could get some function level doxygen done. And of course, so what next? What else is next? So, like last time, I think we're just going to create a bunch of GitHub issues, try and raise some awareness, and ask people to contribute code and make me review your code, and make Yongkang review your code. Anyone else who wants to get involved, please feel free. We have lots of spare time. I say that very, very sarcastically. It shrinks over time, but let's see. One of the issues, one of the topics that I wanted to bring up is, again, AutoSAR, adaptive AutoSAR. So it's built on POSIX. People want to certify their products with Zephyr and Linux, and I think that this is something that we might have to actually start taking more seriously. So the big question is, who's going to do this work? Who's going to pay for it? Because it's not super cheap. I guess it would be most likely auto manufacturers. But with that, we would join a relatively small number of real-time operating systems that are also certified POSIX, compliant, or conformant. In addition to that, we've got ARINC, which is, I forget what that actually stands for. It's aeronautics, something or other, software systems. And one that I've been involved in personally is DSO 178C, which is safety critical aviation software stuff. Relatively new to me as well is this FACE consortium. I'd never heard of that, but it's actually part of opengroup.org, which is the same organization behind the POSIX spec. So this is a way for POSIX to get into aviation. I was doing it, I think, before there was a consortium for this. So for me to see this, I think it's quite amazing. Yeah. So of course, with automotive, with avionics, that sort of thing, we want to have automated systems doing things. And when we have automated systems, we think of AI nowadays, because everybody drives a Tesla and this and that. So everyone wants AI in all their systems. So And they're in everything nowadays. Intelligent vehicles, hyperscaler infrastructure. In your mobile phone, people have these AI accelerators for inference and that sort of thing. If you're doing image detection or, even just human biological motion, like walking and stuff like that. In any case, I know of a great AI company. I've got some stickers if anyone's interested. And I don't want to give away too much, but the future is open source, so I'm looking forward to it. And with that, I'll open up to questions. Any additional questions anybody has? Okay, well, thanks for attending. And I hope we can all get to LTSv3 together. So.